This video is for a couple of problems on the domain and range practice number 1. We are going to do B, C, D, and F, I believe, on this video. So if you need help on any of the problems other than the ones that are on this video, you need to look at the key that's posted on Canvas or ask your teacher for help. Alright, so here we are given a graph. We need to find the domain, the range, and then decide if this graph is that of a function. So let's start with the function part. When I have a graph, remember, to decide if it's a function, you have to see if it passes the vertical line test. This graph definitely does pass the vertical line test, because anywhere I drew a vertical line, it only crosses one time. So this would be a function. Now, domain and range. Remember, your domain are all the x values on your graph, and x's go from left to right. So we need to find the x value that's farthest to the left on my graph and the x value that's farthest to the right. Well, when I look all the way to the left here, it looks like my farthest to the left x is at -6. There's an open circle here, so I'm going to put a parenthesis with -6. Then I have all the x values on this graph all the way until I get to x equals 5. There's a filled in dot there, so I get a square bracket. Now when I look for my range, you need to remember that the range are the y values. So you need to look at the lowest y value to the highest y value. You always start on the bottom. Now when I look at the bottom here, the lowest y value happens to be at -2. Now there is an open dot on the left over here, but on this side there's a closed dot. So the closed dot kind of trumps the other one, and we're going to put a closed dot at -2. My highest y value here goes all the way up to +2, again with a square bracket. Alright, let's move on to D. We start again with deciding if this is a function. So this is a horizontal line. When I draw a vertical line anywhere through it, that vertical line only crosses one time. So this graph is also a function, just like the last one. Now the domain here, just like last time, is your x's. That goes from left to right. Well, if I notice on the end of my graph, on the left, there's an arrow. That arrow means your graph is going towards -infinity to the left. Infinity always gets a parenthesis. On the right, there is also an arrow, which means your graph is going to +infinity in that direction, which also gets a parenthesis. Now the range is a little bit tricky here. Remember, your range is all the y values. And on this graph, it is a constant horizontal line at y equals 3. And that graph never leaves y equals 3. It's never bigger than 3. It's never smaller. It is only 3. So that is actually your range. Your range is y equals 3. We can't write that as an interval, so we have to use set notation here. So that's your curly bracket, and you're going to say all the y's where y can only equal 3. That would be your range. Your domain can be anything, but the output is always going to be 3. Alright, in E, we start with a function. Let's check our vertical line test. When I have all of these ordered pairs, I want to make sure that a vertical line never crosses through more than one point. And it appears that that's the case. Any vertical line is never going to cross through more than one point, so it would be a function. Let me move those lines there. There we go. Now to find our domain. Remember, our domain are all the x's. When I have ordered pairs like this, I want to use the x values for each ordered pair. This is not a continuous graph, so I need to list each ordered pair separately in my set notation. If it's easier for you, write down the ordered pairs. So the ordered pairs here would be -3, 1. The second point is at -2, 0. The third one here is at 1, 4. The next one is at 2, -5. And this last point is at 5, 1. Once I know those ordered pairs, excuse me, you need just the x's from each ordered pair as your domain, and you're just going to list them out. The only x's are -3, -2, 1, 2, and 5. That is your domain. No other values because those are not connected points. Now to find the range, you look here at every y value of your function. And you do it in set notation again. All the y's, where y equals 1, 0, 4, -5. And this last one is 1 again. I already listed 1 up here. I don't have to repeat it, and I can close my bracket. So I can only put these specific x values in, and the only answers I can get for this function are 1, 0, 4, and -5. All right, last one for this practice here. This function here. It is a function because any vertical line only crosses one time. It passes the vertical line test. The domain, again, that's your x's. I always go from left to right. There's an arrow going towards the left forever, which means it is going to -infinity, which always gets a parenthesis. When I come to the right here, notice there's a closed dot, and my graph stops at 4. So your graph does not go past 4, and since there's a closed dot, you're going to put a square bracket. When you look at your range here, you start at the bottom. You go bottom to top. Well, the bottom y value is right on the axis at y equals 0. There's a closed dot there, so it gets a bracket. Now this graph, the arrow is going up and up and up forever. It's going in that upward direction towards infinity. So your range is from 0 to infinity. All right, those are the videos for practice number 1. If you need help on any problems other than those 4, check the key or ask your teacher for help.